Greetings, RB Muki learners. I welcome you to my today's wonderful lesson. Today, let us dive in direct to what we call the questions that pertain to heating curve and also the cooling curve. So, before we even dive in, let's get to understand something pertaining to the cooling curve and the heating curve. So, here it is a topic which comes from matter, as matter is anything that occupies space and has mass. So here's the part again where you need to understand that as we are talking about matter, we need to understand the basic units of matter and also the state of matter. So basic units, we're simply talking about atoms, molecules, and also atoms, molecules, and ion. Then there is also the states of matter where we talk about solid, liquid, and also the gases. Then we must get to understand how they are packed. Okay, we must get to understand on how molecules are being packed on each stage of matter. So now here is the part again where we need to understand the other things, especially upon the two processes, which is the endothermic reaction which happens and also the exothermic reaction. So endothermic and exothermic, here is the part where we need to understand that the heating process undergoes the endothermic wall. The cooling process undergoes the exothermic. Then now here is the part again where we need to understand that the differences between the physical and also chemical reaction. So the physical reaction, or rather the physical change, it is the change that happens when there are no substance formed, when there are no new substance formed. Then chemical change, it's the change where the some of the substance are being formed, like the formation or solidification of a normal salt. So now with this one, we must get to understand, as I mentioned, to say for us to answer this question, we need to understand the heating part of the state of matter, where in that it undergoes what we call the endothermic reaction. So according to the question, they're saying consider the heating curve below of the substance. Now what is this substance? Substance Q. So this is whatever is happening over the substance. The substance, it is called substance Q. So this is substance Q. Then the heating part is started from the constant part, which is, it did not start from 0, it started from below 0, which is a negative 20, meaning it was in form of a solid, particularly ice. So it's negative coming from A to B. From there, then there is this stage, then it's coming from C to D, from this part to this part to also this part. So we must get to understand that as we are talking about those states of matter, the distance that is between A and B, this distance, it is within the state of matter which is solid. Then now from 0, as water begins to kindly melt at what? At 0 degree. In that it is from here to here. So this part, it is melting point. So water begins to melt at 0 degree. Then now here is a part also where we need to understand this stage, which is the stage of what? The stage of solid. Okay, I mean the stage of liquid. This is the stage of liquid. Then now what is it that is happening here? What is it that is happening from solid to liquid? As we are having liquid, what will happen from liquid to gas? What state of matter is this, or what's the change in the state of matter from solid, from liquid to gas? That is part of evaporation. So now we must get to understand now the 4 questions, the way they are being asked. They're saying, number 1, where they're saying, in what state is substance Q between A and B? In what state is substance Q between A and B? So we must get to understand the state of matter from A and B. A and B. So this state, it is the solid state. So we are going to write solid state from there. Then now, in what state is substance Q between B and C. Between B and C. So here it is something that we must understand between this and this. So here it is, that is between the state of solid and what? And liquid. The state that is in both state, because we are coming from this part to this part, it is still constant. Are we getting the point? So it is both solid and liquid. So it is solid and what? And liquid, because they all qualify. Okay, remember liquid, it is upon zero, and also it can be in form of ice, but not completely ice. It can be the waters had to melt from there. Then now we have D, where the C, number 3, where they're saying what is happening between D and E. So D and E, what state? So this is state, remember this is liquid and this is gas. So the state that is happening between the two, it is liquid gas. Liquid and what? Liquid and the gas. Okay, so this is what is happening here. Then now, in what state is this from E to F? E to F, the state from there. Whatever is happening in the state, it is the gas. Why? Because here we are talking about the state of matter, and the state of matter. Solid, liquid, and the gas. So here it is just the gas from there. Now let's reconsider question B, where they're saying what is the melting and boiling point of the substance? What is the boiling and melting point of a substance? So we must get to understand that if we are talking about pure water, the melting point, it is what you call 0 degrees. That's the melting point. Then the boiling point of pure water, it is 100 degrees. Okay, so here's the part where we need to understand this. Okay, so the melting point, the normal melting point, it is 0 degrees. Then boiling point, it's 100 degrees. Okay, so that is it. So for the water to begin to boil, it needs to reach at a point of 100 degrees. And now there is another question where they're saying identify substance Q. So substance Q, this substance, we started boiling at this degree. We started boiling at the degree of 100 degree, meaning it is the pure water. So here the answer, this substance, it is pure water. Okay, why are we reconsidering pure water? Because if we talk about the impure water and the pure water begins to boil at 100 degree, while impure water begins to boil at any degree. So that is it. It boils faster than pure water. So pure water is the one which follows up the prescribed temperature from there. So now here they're saying, how long did it take for the substance Q to change from solid to liquid? From solid to liquid. So how long? What is the degree from solid to liquid? So here we are going to say 15 minus, here there is 5. Here there is 5. So we are going to say 15 seconds minus 5 seconds. The answer, it is 10 seconds. Okay, so that is the answer. The answer appears to be 10 seconds. Okay, lastly, there is this question where they're saying explain why the temperature is constant between B and C. So explain why the temperature is being kept constant. So now, on how you explain, it's where I need you to pay particular attention, because a lot, that is where they do have multiple challenges. So on how you explain why the temperature is being kept constant between B and C, you want to say between B and C, you know that it is melting point, right? It is, it's a melting, that is part of melting. So between B and C, it is melting. Now, it does not mean that the heat energy, it is the one that is being applied here. No, it is because it's not the heat energy, it is because of the heat of the fusion, which happens to do what? Which happens to kindly break the bond between the solid particles which are bonded together. So here we must get to understand that here whatever is happening between B and C isn't what you call the heat energy. So the heat energy does not increase. The heat energy does not increase the tension. Henceforth, it is the heat of the fusion which kindly goes in and breaks the solid particles compacted together. So that is it. So on how they explain, how they say explain the temperature, explain why the temperature is being kept constant. You are going to say it's being kept constant because it's not the heat energy that increases it's not the heat that increases the heat energy or the temperature. Instead, it is what you call the heat of the fusion which breaks the bond, or which breaks the bond of the solid by changing it from solid to what? To liquid, which breaks the solid of the bond by breaking it, by changing it to from solid to liquid. Okay, so that is the answer. So the answer, I'm going to write it here. We are going to kindly say that because heat energy does not